This video is about SCS. SCS means silicon controlled switch. Look at the symbol of the SCS. Then you can observe that the symbol of SCS resembles the symbol of SCR. Among the previous videos, a video on SCR is made. Kindly check out. You can recollect that the SCR has three terminals: anode, cathode, and gate. SCS makes the difference from SCR by having an extra gate terminal. So this makes SCS a four-terminal device with four electrodes: cathode, cathode gate, anode gate, and the anode. Recollect that in SCR, the device gets turned on with a trigger pulse at the gate terminal. So the device gets turned on and it remains in the on state even after the gate pulse is removed. Now, if we want to stop the supply of current to the load, the device should become off. So, removal of power supply in SCR when the current value drops to the value of holding current. But in SCS, we have much more better control because we have another gate terminal which can be used for switching off the device. This makes the main difference of SCS from SCR. The figure shows the basic structure of the SCS and the two transistor version of SCS for the better understanding. The structure of SCS consists of two transistors where the collector of transistor 1 is connected to the base of the transistor 2 and the collector of transistor 2 is connected to the base of transistor 1, which means the N regions of both the transistors are connected and the P regions of both the transistors are connected as shown in the figure. So this forms a four-layered structure and the four layers are PN and this forms the three junctions. And note that like SCR, SCS is also a unilateral device, which means it allows the current to flow in a single direction. And note that gate G1 is connected to the P regions and gate G2 is connected to the N regions. The figure shows the equivalent circuit of SCS. You can observe it is formed of two transistors Q1 and Q2 placed back to back. Remember that the roles of G1 and G2 can be alternated. A positive pulse can be applied at the cathode gate G1 to turn the device on, or a negative pulse at the anode gate G2 will also turn the device on. If we use cathode gate to turn the device on, then a positive pulse at the anode gate will make the device off. And if we use the anode gate Z2 to turn the device on, then the cathode gate Z1 should have a negative pulse to make the device off. This is the equivalent circuit of SCS, clearly showing the potentials. When there is no trigger pulses at the gate terminals, that is, when the device is in the off state, with the voltage Vs, P1 N1 junction gets forward biased, N1 P2 junction gets reverse biased, and P2 N2 junction gets forward biased. Because of the reverse bias at P2 N1 junction, the current flow is blocked and the device is in the off state. Now, when we apply a positive pulse at the gate terminal G1, the holes in the P2 region are pushed towards the N1 region and the electrons of N1 region are attracted towards the P2 region. In this way, the reverse bias gets reduced, that is, the effect of electric field is removed, so the device goes into the on state. Now, when we want to switch off the device, the role of gate terminal Z2 comes into picture. A positive pulse at the gate terminal G2 turns the device off because the gate terminal G2 is connected to the N1 region. This stops the regenerative action that has been established earlier and turns the device off stopping the flow of holes and thus increasing the reverse bias at N1P2 junction. Note that in SCS, forced commutation occurs, whereas in SCR, natural commutation occurs. Natural commutation means the device gets turned off when the main current flowing through the device reaches below the holding current value. And forced commutation means the gate terminal G2 turns the device off forcefully even when the main current flowing through the device has not dropped below the holding current value. Now, let us put the entire understanding of the SCS onto a graph and draw the VI characteristics of SCS. Since SCS is not a bilateral device, you can observe we get the characteristics only in the first quadrant. You can observe the device is initially in the off state, and due to the reverse bias at P2N1 junction, a small leakage current flows, which is shown in the characteristics. And now when the trigger pulse is applied at the gate terminal G1, the device starts to conduct, the current starts flowing, and when it reaches the value of IH, which is the minimum value of current to make the device on, the device gets turned on, decreasing the reverse bias at P2N1 junction. So the voltage gets decreased, that is, the effect of electric field decreases. So a negative resistance characteristic is exhibited by SCS. And after IH, the device goes into the on state and the regenerative action continues. And the device gets turned off when a trigger pulse is applied at the G2 terminal. This concludes the topic of SCS. If you like the video, subscribe to my channel, like and share the video. Kindly help me to help you.